Hello, good morning my warriors. Welcome aboard to the next session of Zero to Hero series with me, Shreyas, your master teacher for physics at Vedantu going live. Nice to see all of you in the morning. Hello, Yalini, Priyanka, Aman, Sakshi. Aman, I'm very good. How are you? I hope you're doing fine. Hi Nancy, good morning. Hi Samuel John, how are you? Hi Amu, hi Shreyas Kapri. Welcome aboard. Good morning all my new warriors as well as my old warriors. Hi Sai Telugu, hi Aditya, hi Aishwarya, hi Ankit, hi Abhijit. So guys, remember, if you are new to this channel, the only way you can make friends is when you interact with all the other students, in the chat box. So say hello, mingle with each other, help each other, support each other, and make sure if somebody spams or somebody is a virus, make sure to throw them away and report them. So welcome aboard. Hi Music Stories, hi Madhavan, hi Pawan. Good morning everyone. And guys, I am Shreyas and I am the master teacher for physics at Vedantu going live. And I not only conduct my classes on YouTube, but also on the pro subscription as well as, all the other Vedantu platforms which are there on mobile or on, the web browser. And if you want to know more about me, you can definitely follow me on my Instagram handle, that's Shreyas_Vedantu. And do not forget, before we begin the session, please smash that like button out there. Yes, you can see it down there. And do not forget to hit the subscribe button so that you do not miss any of my classes. Also remember, the entire PDF, updates, news, and all important notifications will be directly given to you in the Telegram channel. And you can join the Telegram channel by the link which is there in the description box below. So go check it out. Hello Gopal, hi Rashmi. Welcome aboard. How is everyone? Nice to see all of you. Yes, Vikram, let's rock it. Now today's lecture is going to consist of 3 different things. So in this session today, we're going to talk about, kinetic theory of gases, heat capacity of gases and all that. And then the laws of thermodynamics along with heat engines problems. So all different types of problems, so that you become a hero by the end of the session. You get that confidence to solve the problems so that you have adequate practice of different varieties of problems. That's the intention of these series for all the 2021 aspirants. Even if you are 2022, you can still watch it. Tonight we are going to have vernier caliper and micrometer screw gauge, that's for 11th standard, and then the 12th standard series. And again, zero to hero and capacitors, just because you guys commented in the comment box in the previous videos. So zero to hero at 9 o'clock on Thursday, and then Menti quiz for 11th standard and a special session for you guys on Saturday. Okay, so that's the whole plan. Hello Kashmir the Paradise. Okay, hi Rashmi, glad to know that you have started attending my classes from yesterday. Hi Sayandeep, good morning bacha log. Hi Ajit K, good morning. Welcome aboard. And guys, remember, we have special plans for you, and you need those special plans because I know you are very tensed for your upcoming JEE Mains examination. It has been indefinitely postponed, including your board examinations. Now, the reason why we come up with plans is because, and we continuously support you guys, irrespective of whether the exams are postponed, not postponed, how much duration it is postponed, because we want you guys to be a topper just like this. Look at these people out here, 99.96 percentile, 99.97 percentile. These are all Vedantu students who have, made Vedantu as the topper's new address. Earlier it used to be Kota. You don't have to go to Kota. It's done. Ho gaya. 10 years back, 20 years back, people used to go to Kota. Now it's a new address, and that's Vedantu. And even if you check out the results of Vedantu, compare it with others, I mean, these are the Vedantu students, how they are performing. Even in the board examinations or even in JEE Advanced, you can see the performance is 3 to 6 times better than the students who study outside or elsewhere in any other online or even offline coaching institutes. So guys, if you want to boost your performance, we have a crash course which has just started yesterday, 17th May, and it's going to continue for 1 month. It includes test series, it includes notes, replays, 11th and 12th standard complete revision with problem solving, and also doubt solving within the Vedantu app, free doubt solving. All this is included in a package, not for 10,000, for 6,000 rupees when you use the coupon code. And I'll tell you, you can even pay 2,000 rupees and still avail this offer. Yes, you can even pay 2,000 rupees for the crash course. I know many of your ears and eyes have opened up now. How can you get the crash course for 2,000? I'll tell you a trick by the end of the session. Okay, for now, let's start revising all the problems and the formulas out here. Let's start with KTG. Hello, Shalini, thank you so much. Hi, Rahul, good morning. Okay, Chala Baundi. Okay, I guess Shalini, that's Telugu. Chala is very and Baundi is good. So I think it's like very good. Okay, I think I get it. Yes, hi Vizaro, welcome aboard. Now the first formula that you're seeing on your screen out here is, the general gas laws equations and Boltzmann constant. This K is nothing but your Boltzmann constant. Boltzmann constant. Okay, you should know that Boltzmann constant is gas constant R divided by Na. Out here, yes, keep this in mind. Oops, okay. And so Rashmi, you'll get the PDFs from the Telegram group. The link for joining the group is there in the description box below. Okay, then Na is nothing but Avogadro number. We all know that. All right, 6 into 10 to the power 23. That's the Avogadro number. RMS speed, root mean square velocity is root 3 RT by m. Please understand this m is the molecular weight. The molecular weight of that gas, 3 RT by m. Average speed is 8 RT by pi m. Only these constants change, and for most probable speed it is 2 RT by m. So you can write this as, in fact, 2 RT by m. They have converted it into K. You can do that because R by Avogadro's number is K. You can convert all of that. That is also allowed. Hello Anushrut, welcome aboard. Hello Nandita, good morning. Hi Anushrut Reddy, good morning, welcome aboard. Start attending guys. I'm pretty sure you will start enjoying the Zero to Hero series, and in case you have missed any of the previous sessions, you can still freely watch it from our playlist of Zero to Hero. So go ahead, check it out, because this is going to be your preparation playlist, preparation lecture series for JEE 2021, be it mains or advanced. So become a hero attending all the sessions out here. Then this equation is also a very important equation, which is the main equation of kinetic theory of gases, and it says PV. You can also write this equation as pressure into volume is 1/3 number of molecules, all right, nm/v/rms square. You can write it as nm/v/rms square. This is also a very, very important equation. PV is equal to 1/3 nm/v square. Next one is law of equipartition of energies, which says that the total energy of a gas gets equally divided into each degree of freedom. So there are different degrees of freedom. Like for a monoatomic, there are 3 degrees of freedom. For a diatomic, there are 5 degrees of freedom. So each degree of freedom gets half kT energy. So if there are F degrees of freedom, then the total energy of a molecule will be F into half kT. K is Boltzmann constant, remember that, R by Na. So half kT is the energy per molecule per degree of freedom. That's what law of equipartition of energy says. Then the internal energy of any internal energy of any gas, this is very important formula. U is equal to F by 2 nRT, which is nothing but nCVT. I hope you remember this, because CV is nothing but F by 2R. Remember that CV, specific heat capacity at constant volume, is F by 2R. So it is nCV into T. Very important, internal energy of the gas. So Karimullah, I think if you have paid 6,000 rupees already, then the classes will start showing up in your schedule. And if you're still not able to find it, please ping me on my handle, Shreyas_Vedantu. I will guide you step by step how you can start attending the classes. Anyways, it will start showing up automatically in your dashboard out there. Okay, so these are very important formulas out here. Next, up there, okay, relationship between U and CV. I just told you, U is nCVT. So delta U will be nCV delta T. Remember that. Change in internal energy will be nCV delta T. Just U will be NCV into T. That's the difference. Okay. Now whenever you mix gases, you might have to find the effective CV or effective CP or effective gamma. Gamma is CP by CV, remember that. In those situations, use this formula directly, looks like center of mass formula, and you will get, you know, the effective CV or effective CP. So all you need to do is basically CV is N1 CV1 plus N2 CV2 upon N1 plus N2. That's the CV of the mixture. Similarly, CP of the mixture. CP of the mixture, this is actually CP guys, this was supposed to be CP. CP of the mixture is N1 CP1 plus N2 CP2 upon N1 C, okay, this was N1 plus N2, okay, N1 plus N2, and then the gamma of that mixture, alright, the gamma of the mixture will be CP by CV. CP is from here and this CV is from here, keep this in mind. So gamma of the mixture will be effective CP divided by effective CV. Keep this in mind, okay? That's how it works. Last one. Remember this, for monoatomic degrees of freedom are 3, for diatomic degrees of freedom are 5, for polyatomic it could be 6. Now generally in JEE Physics you get only monoatomic and diatomic. Only in chemistry you have those triatomic, linear, triatomic, non-linear and polyatomic gases. But generally in physics you get only these kind of problems, mono and diatomic out there. Okay, so these are important formulas and I hope you have noted it down. Let's start actually solving these questions. Only through the questions you'll get a proper understanding of KTG. Let's see whether you can get this. The temperature of an ideal gas enclosed in a enclosed in a chamber is raised from 300 to 600 Kelvin. You increase the temperature from 300 to 600. That gas is, you know, enclosed in a chamber. How will the pressure become double? Why will the pressure become double? Which of the following reasons justifies the doubling of the pressure? Come on, think about it. Wow, Samuel, that means a lot. Don't worry, Samuel, it will be worth it. Okay? Okay, yes. Glad, Rashmi, you're understanding. Okay, Karinula, I'm guessing you will get the Telegram group link as well as download the PDF later on. Okay, Anushrut says 6. I'm not sure what is 6, but yep. Oh, I think you are referring to the degrees of freedom of polyatomic gases. Anything awesome says either option C or B. Come on, all the others. Hi Tarun CR, you are a little bit late, but you can always watch the replay even after the session is over. But the fun of attending live class is very different and you cannot probably get that fun in replay. So attend the live class now. Whatever small part you miss, you can watch it later on. Okay, come on Sai Telugu. Come on guys. Figure it out. Which of the following justifies the doubling of the pressure? Hi, good morning Shweta S. Welcome aboard. So guys, try to recollect the formulas and probably you will get it. Come on. Figure it out, my warriors. The pressure becomes twofold because I hope you remember this formula. PV is equal to 1/3 Nm VRMS square. I just gave you this formula. PV is equal to 1/3 Nm VRMS square. Now, a gas which is enclosed in a chamber, because it is enclosed in a chamber, that means this volume is nothing but a constant. Now these are nothing but the number of molecules and the mass of a molecule, so these are anyways constant entities. Now what is VRMS proportional to? VRMS is directly proportional to the root of temperature. Do you remember that? VRMS is 3 RT by M. So it's directly proportional to the root of temperature. So think about it. If the temperature goes from 300 to 600 Kelvin, that means the temperature has become 2 times. If temperature becomes 2 times, RMS velocity will become root 2 times. It will become root 2 times. I hope this is clear. So the square of RMS will become root 2 square. Root 2 square, guys. What is root 2 square times? Root 2 square is nothing but 2 times only. So hence the pressure becomes 2 times. So which of the following justifies it correctly? The root mean square velocity becomes root 2 times and hence the pressure becomes 2 times more. Yeah, the correct answer is B. Hello Thrimbakam, welcome aboard. Do not spam out there, bacha. Yes, start solving all the questions and follow whatever I am saying, okay, in case you do not get the answer. It's okay. You might not get it. So that's why understand through my explanations why the answer is correct, which option is correct, how we are approaching the problems. That's the intention of Zero to Hero series, so that you get conceptual understanding plus problem solving aptitude. Okay, so that's the answer, option B. Let's see whether you can solve the next question coming up on your screen. Okay, come on. Think about it. Okay, so which one of the following graph represents the correct behavior of an ideal gas? Come on, which of the following represents the correct behavior of the ideal gas? Come on, think about it. Come on. So option C was not correct. Anything awesome? So just because, see, pressure can increase because of number of things. Maybe the molecules doubled, or maybe the molecules were same but their speed doubled. So in the previous case, it's not the number of molecules which have doubled which are striking the wall, because of which the pressure doubled. In fact, the speed of the molecules has become so many times so that the pressure increases. So understand, that's why the option C was not correct in the previous one. Okay, come on. A lot of you are saying A, some of you are saying D. Well, the correct answer is actually D, and the reason for that is simple. Guys, ideal gas equation is PV is equal to nRT, correct? Just take the temperature below, you will get PV by T is equal to nR. Now N is a constant, R is a constant, so think about it. PV, oops, I think this graph is wrong. Okay, so PV by T is nothing but a constant. PV by T is nothing but a constant. That means PV is directly proportional to T. So it's not option D, it's option A. Let me just correct it out here. The option given over here was wrong. Okay, I'm just going to correct it, guys, so that in your PDF you have the correct answers. Just going to correct it right away. Okay, yep, there we go. Yes, this is the correct answer. So PV is directly proportional to T. So option A is correct. A lot of you said option A, some of you said option D, I'm not sure why, but option A is correct. Okay, keep this in mind. Pressure into volume is directly proportional to temperature. If it is directly proportional, it will be a straight line. Okay, let's see whether you can solve this. This is very tricky. A lot of people make a lot of mistakes in this. Many times I have seen people making mistakes in this. Let's see whether you can get this correct. Two vessels, same volume of atomic hydrogen and helium at pressures of 1 atm, 2 atm are filled. Temperature of both of the gases, hydrogen as well as helium, is same. The average speed of hydrogen atom and helium atom, the average speed, how are they related? Come on, let's see how many of you can do this. It's very tricky. Many times people will make a mistake in this problem. I've seen this. Come on, let's see how many of you can do this really quick. Got it, says Tharun CR. Come on, my warriors, let's see. I'm reading all your chats. Kaushik Nihal says A. Come on, Samuel. Okay, I think you guys were talking about the previous question. Think about this question. The Zero to Hero series. Welcome all the new warriors. If you are new and watching this lecture right now, even if you are late, it's okay. Continue watching. This is for all the JEE 2021 and even the 2022 aspirants. So this is intending to improve your scores. This is started with the intention of making you understand the concepts via the problems and making you understand how to exactly apply those concepts while solving the problems and getting that approach so that your scores improve. Okay, come on, let's see. Average speed formula, music stories I just gave you. Try and recollect. What is the average speed formula? 8 RT by pi m. Root of 8 RT by pi m. Some of you are saying C, some of you are saying A. So now think, these things are useless. This 1 atm, 2 atm, same volume, all these are useless. Why are they useless? Because the average speed is root of 8 RT by pi m. It's not dependent on the pressure, it's not dependent on the volume, it's only dependent on the molecular weight and the temperature. So other things are completely useless. They have just been given to confuse you, no other intention. So the examiner will always try and do something like that. Now it is also given the temperature of both the samples is same. Even T is same for both of them. That means the speed is inversely related to the root of the molecular mass. Yes, hence what I'm going to do, the velocity of hydrogen, okay, the average upon velocity of helium average is nothing but root of molecular mass of helium upon molecular mass of hydrogen. So it is inversely proportional to the root of molecular mass. Now think about it. What is the molecular mass of helium? Isn't it 4? And what is it for hydrogen? What did you put over here? What did you put over here? I know a lot of you are going to make a mistake over here. Let's see how many of you wrote the right number over here. What is the molecular mass of hydrogen, guys? Come on, think about it. Come on, guys, think about it. What should be the molecular mass out there? Let's see how many of you wrote the correct thing. Come on, think. Come on. Think. What is it? Is it going to be 1, 2, 3, 4? Come on. Oh, Harsh, congratulations. Read the question carefully. It's atomic hydrogen. If it is atomic hydrogen, guys, that means it is 1. It was not hydrogen gas. Be careful. If it was hydrogen gas, then it would be 2, but it is atomic hydrogen, that's why it is 1. So that's the common mistake, and root of 4 is 2. So 2 is to 1, and hence the correct answer will be this. Hydrogen speed is 2 times the helium molecule speed. Lot of people make that mistakes. See, look at that. So many people have made the mistake. Okay, so it was atomic hydrogen. This word is very important. If it is atomic, it is 1. If it is a gas, it will be diatomic, then it will be 2. So that time you need to be careful. Yes, that time the option will be A. Yep, correcto. Let's get going. I hope you understood and you saw what kind of mistakes you can make in the actual examination. So that's the whole idea of Zero to Hero series. Let's go ahead to the next question. There is a jar which has a mixture of hydrogen as well as some other gas, oxygen. Actually, hydrogen and oxygen, that should have been the wordings. So let me just change it. Hydrogen and oxygen. Okay. So let me just put it over there. Hydrogen and oxygen gases in the ratio, okay, in the ratio of 1:5. What is the ratio of the mean or average kinetic energy of hydrogen and oxygen gases? Come on, let's see how many of you can do this really quick. What is the answer? Come on. No problem, happens music stories. Okay. Even if you do it like that, anything awesome. Even if you thought root of 3, okay, by P by V, you can always convert it into temperature and R and M. So always try to bring it in that form, because temperatures are more important than pressures and volume in most of the problems. No problem, Sakti, join in. Your missed few questions and good and tricky ones, just like Tarun is saying. You can watch the replay later on. So guys, what do you think will be the answer? What do you think will be the answer? What is the ratio of the average kinetic energy of hydrogen and oxygen molecules? So the answer for this, think about it. It's clearly mentioned, it is a mixture of gases. And once they are a mixture of gases, understand the temperature will be same. Alright, temperature will be same for both of the gases. If temperature is same, understand the average kinetic energy will also be same, because temperature is a function of energy. It depends on kinetic energy of the molecules. If two gases have same temperature, then their average kinetic energy is same. So hence, don't you see their ratio of kinetic energies should be 1:1? Yep, average kinetic energy will be same. Hence, understand the answer is 1:1. That's as simple as that. This number 1:5 is useless. They have just given you to confuse you again. Lot of tricky questions. It just shows you how your brain thinks, how your brain gets confused, gets deviated looking at those numbers, and you start thinking in a very different line. So understand, if you know your concepts thoroughly, you will not get confused. So average kinetic energy depends only on the temperature, hence the answer is 1:1. Okay, next question. Let's see how many of you can do this. Hello, good morning, Gauri. Yes, Rashmi, let's get going. Yep, Tarun, 1:1. Yes, Aditi, 1:1. D option. Yes, Mr. AK Hunter. Yep, let's get going. Shreyas Kapri says clearo. Okay, yes, at absolute zero temperature, kinetic energy is 0 side telgo. Correcto. Okay, a polyatomic gas with n molecules with f degrees of freedom has a total average kinetic energy given by? What's the total kinetic energy of a gas which has n molecules, each molecule having f degrees of freedom? K is your Boltzmann constant, T is your temperature. Let's see how many of you can get this. Hello, Atrita Ganguly, good morning, welcome aboard. Okay, Samla says D. Okay, Anaka Kulkarni has understood this. Very beautiful, very good. Come on, my warriors, think. What should be the correct answer? Some of you are confused between D and C. Let's see how many of you can actually get this. Okay, come on, my warriors. Okay, the correct answer is actually C. Now I'll tell you why. Okay, remember law of equipartition of kinetic energy said per degree per molecule the energy is half kT. This is per molecule. This is per molecule per degree of freedom. So the kinetic energy of that gas will be half kT. How many degrees of freedom are there? F. So because per degree this was the energy for F degrees into F, and this was per molecule. How many molecules are there? N molecules. So into N. So NFKT by 2. So NFKT by 2. You can see that that's option C, and hence that's the answer. Law of equipartition of kinetic energy. Yes, a lot of you got it correct. Beautiful. I think Nancy got it correct. Samuel John got it correct. AB D Salam got it correct. Anu also got it correct. Yep, Mr. AK Hunter, Ankit. Very good, Samla. Excelente. Hello, Krishna Priya. Welcome aboard. Join in to We Enthuse channel, which is an exclusive English medium channel for all the JEE aspirants, and we are in the Zero to Hero series, just like you can see in the scrolling text for all the 2021 and even the 2022 aspirants. So get ready. Lots of questions to be solved. We're just, probably not even halfway yet. Okay. Find out the degrees of freedom expression. If gamma is the ratio of Cp by Cv, come on, let's see how many of you can do this. Yes, Krishna Mohan got it, and Karishma is also very happy to get the correct answer. What about option 4? Karimula says option 4 is wrong. 3 by 2 kT is not the correct answer because neither degrees of freedom is there nor number of molecules are there. So obviously it is wrong. Okay, come on, my warriors. Ankit says B. Samla says A. Okay, Tarun says easy. Come on, Tarun, do this. Directly formula based question. You should be able to do this. If you remember the formula for degrees of freedom, you will be able to do this. Come on, guys. I mean, gamma, there is a formula 1 plus 2 by F. I don't know whether you remember this. If you've forgotten, now remember. This is a very important formula. Now just rearrange. So therefore, gamma minus 1 is 2 by F. Now flip it. So 1 upon gamma minus 1 is F by 2. Now take that 2 over there. So therefore, what will F be equal to? 2 upon gamma minus 1. Which of the following is correct? Option A. Yep, option A is correct, guys. As simple as that. If you know the formula, you get it. These kind of questions have come in JEE Mains, February, March attempt, and even previously. A lot of people missed out on these questions because they do not know formulas. So guys, please attend all the classes live out here so that next time you see a question in your next attempt, you do not miss that and you do not lose those 4 marks or get a negative mark. Because I want you to get those 4 marks. Only then you are going to get a good score. Attending this series is going to boost your score, and that's what has happened in the February and March attempt. Those of you who are attending my mock test, Sure Shot 60, and all those PYQ series out there. So guys, come on, if you want to boost your rank, keep attending the classes out here. Now, a lot of you who have doubts, remember you can send in all your queries, all your doubts, screenshots. You can even ask whether this solution is correct or wrong in the Vedantu app itself. Yes, just open the Vedantu app, go to this section called as ask any doubt from morning till night, unlimited, from any book, any chapter, 11th or 12th, doesn't matter. And you can even chat with our doubt experts. You can see where you went wrong, take some hints for solving the questions. All of this is available for free if you are a pro user or if you are subscribed under the crash course. So it's available for free of cost. Remember that. So check it out. It's a very useful feature. Sometimes people do forget that, oh, we can actually ask doubts. Next, let's go to laws of thermodynamics. out here. Okay, so anything awesome? Just try and recollect laws of equipartition of kinetic energy. All right, so which says per degree of freedom half kT energy. So for F degrees of freedom, half kT into F. For N molecules, half kT into F into M. That's it. That's all. Okay. Yes. So now laws of thermodynamics. The first law, very simple. Heat supplied is delta U plus work. Standard. Q is delta U plus work. This is how it is in physics. Remember that. And remember, work done is positive for expansion and it is negative for compression. So this is how the sign convention works. Okay, it's completely opposite in case of chemistry. Now in general, this is a general formula. So the general formula is that work done is P delta V or integration of P dV, which is also nothing but area under P versus V graph. For isothermal, that is when temperature is constant, the work done is nRT log of V2 by V1. That's the isothermal formula. When it is isobaric means pressure is constant. That situation, it is P into final volume minus initial volume. As simple as that. For adiabatic, it is P1 V1 minus P2 V2 upon gamma minus 1. So adiabatic means Q is 0. Heat is 0. No exchange of heat. There is no, transfer, and even PV raised to gamma is constant. In fact, it has been mentioned out here. So for adiabatic, PV raised to gamma is constant. Heat supplied or absorbed is 0. Isochoric, that's when volume is constant. When the volume is constant, there is no work done. That's a special situation out there. Yep. So Rashmi, like I said before, you're going to get all the PDFs, okay, in the description box later on, not now. Okay. Is there a derivation for adiabatic formula? Yes, Sakti, you can check out HC Verma or even NCRT. Probably you're going to find it for sure in HC Verma. Okay. All those derivations are there. But remember, right now, if you are a 2021 student, do not focus on derivations. Now is not the time. Okay. So for you guys, it's very important. Just go for the concept application, problem solving. If you go into derivation, if you go deep into the problem at molecular level, then that's it. You do not have that time. You're just going to waste your time, and a lot of people then get carried away in different approaches, different ways, and that's it. You lose it. Okay. So now is not the time for doing that research. Remember that. Okay. Let's see how many of you can solve this problem. When heat is added, when you add some heat to a system. Oops, this was not supposed to be shown. Oops, this was not supposed to be shown. Okay. Okay. So when heat is added to a system, which of the following is not possible? Which of the following is not possible? Okay. So guys, when heat is added to the system, which is not possible, think about it. Let's do this. I mean, it's not that difficult to see. Q is equal to delta U plus work. When heat is added, that means when Q is positive. If Q is positive, LHS is positive, so RHS together must also be positive. Now check which of the following cases is positive. Check which of the following cases is positive. Just think about it. Come on guys, visualize this. Yep. Internal energy of the system increases. Internal energy of the system increases. Is this possible? Yes, I think so. That means delta U is positive. Yep. So if LHS is positive, maybe delta U is positive. Yes, so this is possible, definitely. Work is done by the system. That means W is positive. Okay, W is positive. Yes, that is also possible. RHS is positive. Okay. Neither delta U nor work is there because no work is done, no change in internal energy. So delta U is 0. Work done is 0. How is this possible, guys? How can RHS be 0 when LHS is 0? So obviously this is not possible. And internal energy increases and work is also done. That means delta U is positive and work done is also positive. So if both are positive, yes, RHS is positive, LHS is also positive. So yes, LHS can be equal to RHS and hence this is possible. So the only thing which is not possible, which of the following is not possible? Read the wordings carefully, and that is option C, guys. Option C. Yep, I hope this is clear. So that's how this works, and that's why option C is correct. I know the answer got out before we started. But anyways, let's see whether you can solve the next question coming up on your screen. Okay, come on. Okay. Hey Vishruta, very good. It's your birthday. Many happy returns of the day. Hope you do really well. God bless you and stay safe and stay put and study well. All the best for your exams and your life as well. Okay. So hello Sanjana Sharma, welcome aboard to the Zero to Hero series as well as Enthuse channel. Okay, so Anaga says clear. Yes. Let's see whether you can do this. Work done in an adiabatic change in a particular gas depends on which of the following? Change in volume, change in pressure, change in temperature, none of these. Okay, come on, all my warriors, think about this. Think carefully. Okay, so the work done in an adiabatic gas. A lot of you are saying B, some of you are saying C. Oh my God, some of you are saying A also and some of you are saying D also. Okay, looks like you guys have forgotten the formula. So guys, I just told you the formula for work done. The formula for work done in an adiabatic process is P1 V1 minus P2 V2 divided by gamma minus 1. That's the formula. Now what is P1 V1? P1 V1 is nothing but nRT1. What is P2 V2? It is nRT2 divided by gamma minus 1. Now take out nR common and even gamma minus 1 common, and you will get T1 minus T2 over here. Gamma for a gas is constant, N is constant, R constant. What is it dependent on? What are these numbers, guys? These numbers are nothing but temperature, so it only depends on temperature change, not on the pressure, not on the volume. Yes, it might depend indirectly, but not directly. So only final and initial temperature matters for work done. That's the answer. Beautiful. A lot of you got it wrong, so be careful. If you remember the formula, you will get this. This is directly formula based question. So that's it. You have to just play around with that formula. So answer is C, which is change in temperature. Okay, come on. Let's do this. Yes, a lot of you say Capto, understandable. Thank you, Yalini. Yes, Rahul. Yes, Sonu, temperature. Love for temperature. Sonu, these days people are scared about temperature because nobody wants temperature. Yeah, it's very scary. Ask me about it. Few weeks back, I was so scared about temperature. Okay, Priyanka got it. Very good. Okay, Krishna Mohan, come on, figure it out. An ideal gas is taken through this process ABCA and the net heat supplied is 5 joules. The net heat is 5 joules. What is the work done from C to B? Please understand, this marking is not there. You do not know what is the pressure over here. This is very tricky. Many people are going to make a mistake. I just did it, Samla. You asked for it? Come on, there it is. Come on, let's see how many of you are going to do this question properly. Oh, by the way, Samla, I did a graph based question even before this at the start of the lecture. Okay, in case you missed it, please watch the replay. Okay, come on, guys. And if you want more questions, guys, please watch the flash series and don't worry, also attend the mock test. We are going to do lots of questions. So understand, we are doing zero to hero work. Zero to hero on thermodynamics. I have to take all kinds of questions, but if you want more questions, there is flash series. Also, we are going to conduct mock test, plus the crash course is also there. So please join the crash course so that you can get even more questions for practice. Okay, a lot of you are saying D or C. Okay, come on guys, visualize, figure it out. There is a catch in the question. Let's see how many of you can do this. Okay, let's start solving the question. Yes. Okay, now the whole idea of solving the question is to find the C to B. Okay, the work done by the gas in C to B. Okay, let's do this. I think, guys, 1 second, this was not supposed to be C to B. I'm so sorry. This was not supposed to be C to B. Okay, this was supposed to be C to A. I don't know why. Oh my God, there are a lot of mistakes, guys. I'm so sorry for today. This was supposed to be C to A. Okay, I'm so sorry. Anyways, so let's start solving this question where the question was actually C to A process. What's the work done? Okay, let's do this. Okay, now the whole idea is, the total work done, okay, the total work done in that cyclic process, is work done from A to B plus work done from B to C plus work done from C to A. Work done from A to B plus B to C plus C to A. Now, in a cyclic process, what is the total work done? In a cyclic process, what is the total work done? It is the heat supplied in that cyclic process, if you remember that. Total work is same as heat, because delta U is 0. Delta U for a cyclic process, any cyclic process, is 0. Now, what is the work done from A to B? A to B. Be careful, this is not pressure versus volume. This is volume versus pressure. Volume versus pressure. So you need to be really careful about it. So you need to take this area. Yes, you need to choose this area for the work done. Be careful, not this area, but this area, because this is pressure versus volume. A lot of people make a mistake and they say it is 0. This is volume versus pressure. Now what is this area? Think about it. What is that area? That area will be this height. How much is the height? 1 into this entire length. How much is this entire length? That is 10. So it is basically 10. And you can see the volume has increased. So that's why work done is positive. So understand it is plus 10 joules. Yes, it is plus 10 joules out there. Yep. A lot of people make that mistake. It's volume versus pressure. So you need to choose this area and not that area. And this is 1, this is 2. So the height is 1 and this length is 10 units. So 1 into 10 is obviously 10. It's a rectangle. B to C. Now B to C, the volume is constant. You can see that. Volume is constant. So that's why the work done over here is 0. A lot of people make that mistake. They take this area. No, this is volume versus pressure. Volume is constant. Isochoric process, work done is 0. Common mistake. And plus work done from C to A. Now what is the heat supplied in that cyclic process? It is clearly mentioned to be 5 joules. So 5 is equal to 10 plus work done from C to A. So work done from C to A. Okay. Oops. Work done from C to A is nothing but how much? 5 minus 10, which is minus 5 joules. And that is option A. Option A. Beautiful. Yes. A lot of people might have made some mistakes with that signs out there and they would have got some different answer. Okay. So that's how it is. Surya, I have taught electromagnetic waves in the flash series. Please watch the flash series, and I have already replied to your comment. So please don't spam out here. And if you want that lecture, then please join the pro subscription. You will get it, or else wait for the Pathfinder series till I do it. So don't unnecessarily trouble me out here by spamming the chat box. I hope I have made things very clear. So don't blame me out here by posting random comments again and again. So do not spam out here, or else you will be blocked. Remember that. Okay. Chalo. Let's get going to the next question. Okay, I'll just change the question out here so that in your PDF you get the correct and question out there, so that there is no mistake. Okay, there we go. There we have changed it. Yes. So I've changed it to C to A. Please keep that in mind. Okay. Now, next question. 1 gram mole of an ideal gas, it expands adiabatically from initial temperature Ti to final temperature Tf. Initial temperature Ti to final temperature Tf. Then the work done is, come on guys, you should be able to do it. Come on guys, think carefully. 1 gram mole of an ideal gas expands adiabatically from initial temperature Ti to final temperature. Okay, a lot of you are saying C. Some of you are even saying A, I guess. Very few are confused between C and D as well. Now the logic behind this is, okay, now what kind of process is this? This is adiabatic. Now in adiabatic process, Q is 0. Now if Q is 0, understand delta U plus W is 0. That means W is equal to minus delta U. Now what is the formula for delta U? It is N CV delta T. N CV delta T is the formula for delta U I just gave you. How many moles are there? 1 gram mole, that means 1 mole. Okay, CV is CV and delta T is final temperature minus initial temperature. Take that minus sign inside, you're going to get CV into T initial minus T final, and that's going to be option A. Yes, that's option A. Yes, that's option A, guys. Lot of you got a wrong answer. Yes, lot of you got the wrong answer. Be careful. Be careful. It is not C, it is option A. Be careful, guys. Okay, so that's how it is. It's just usage of formulas. Many formulas are used. First law is used. The definition of adiabatic process is used. The second formula used is delta U is equal to NCV delta T, and then substitution. 1 gram mole is 1. This was final minus initial. A lot of people might make a mistake, T1 minus T2 and all that, and that's it. Solve it properly, you will get the answer. Okay, great. Okay, so Vishruta is distributing virtual cakes for all the people. My God, poor Vishruta had to type so many cakes for all the people. Thank you, Vishruta, so much. Okay, a lot of you made the mistake. Looks like everybody is surprised and shocked. Oh my God, we thought C, and how the hell is the answer A? So that's the whole idea. That's the whole idea of these series, guys. Okay, next question coming up on your screen now. Okay. Perfect gas is found to obey the relationship this one, and this is constant during an adiabatic process. If such a gas initially at certain temperature is compressed to half its initial volume, then the final temperature will be. Very interesting question. Let's see. So easy it has become to just distribute virtual cakes. Guys, you should all note down all the birthdays of all the warriors and minions out here, so that if you ever meet or bump into each other, then you should be like, hey, your birthday, remember virtual cake? You distributed it during Shreyas Sir's class. Come on, where is the actual cake? Yes. Yo, come on. Tarun says, I think she is also virtual. Arey, Tarun, such a big blame game. My God. Can we use work done in adiabatic process and solve the problem? Yes, Raja Raman, you can definitely do that. Still you will get the same answer. Definitely. Yesterday only I ate cake. I think I told you guys, if you have attended my Pathfinder series, I just ordered 2 cakes and I had it because I was very bored and I didn't know what to do. Yeah. So my birth date, Shreyas, it's 15 July. Is this the first lecture of thermodynamics? No, Aarti. This is the second lecture in the 0 to Hero series. In the Flash series, I have conducted all the lectures of thermodynamics. Okay, let's start solving the question out here. Okay, and there we go. PV raised to 3 by 2 is constant. Using gas law, using the gas laws, gas law equation, pressure is nRT by V. So pressure is nRT by volume, and V raised to 3 by 2 is a constant, correct? Now nR you can take it out on the other side, okay? And temperature, I'll just keep it here. So T into V raised to 3 by 2 by V is equal to constant by nR. Now this can be written down as T into V raised to 3 by 2 by V. Obviously, it will just become V raised to half or root of V, correct? V raised to 3 by 2 minus 1 is V raised to half. V raised to half is nothing but the root of volume. And this is also a constant, so it will become a new constant. It's a new constant. So T into root V is a constant. Okay, now keeping this in mind, now let's solve the problem. In this process, it is compressed to half its initial volume. It's compressed to half its initial volume. So volume has become half. Volume has become half. So if volume becomes half, think about it, root of volume will become root of half. Root of half, think about it. So the root of V will become root of half. But the product should remain constant. The product should remain constant. So if volume has become half, root of volume has become root of half, so temperature should become root 2 times. Correct. And hence the answer is C. This is root 2. I hope you see this. This value is nothing but root 2. So root 2 times the final initial temperature, that's the change. Yes, option C is correct. Beautiful, Tejas, Ishwar, Sakti, Hiranmay, Veer, Nancy, Anaga. Excellente, Rajaram. Excellente. Very good, very good. That's how you can solve this question. Beautiful. Okay, that's option C. Now next question is also very amazing. Let's see how many of you can do this. Lot of times there are questions on chambers, different gases and all that, and then you have to find the different things at equilibrium. So exactly a similar question out here. Two chambers, this side volume is 5E, this side volume is V. This side pressure is P, this side pressure is 10P. Now because the pressures are different, the volumes are different, the pressures will equalize eventually and it will attain equilibrium. This dotted line in between is a piston, so it can slide towards right or left till it attains equilibrium. So one gas might expand, one gas will compress obviously, and it is clearly mentioned that it is an isothermal process. Whatever happens, the temperature of both the gases remains same as well as constant. Keep this in mind. Now the question is, eventually when they attain equilibrium, what are the final volumes of the gases? Come on, what are the final volumes of the gases? Come on, think about it. Beautiful question which is there on your screen. How do you figure it out? Think about it. Thank you, Sakshi, so much. Chaitanya ji, that's why I have conducted 0 to Hero series. So, watch my 0 to Hero, and if required, watch the Flash series. That is crisp. In 3 to 4 lectures I have covered it. So, you will be able to cover. Plus, you have time, na Chaitanya ji, because the exam dates are not yet announced. So, if the exam was in 2 weeks, then it was a difficult task. But I'm pretty sure it is not going to happen in May. It's going to happen somewhere in June, and they are at least going to give you 15 days of notice. So you have time. Don't be lazy. Work hard for studying the chapters. Just because it is lengthy, if you leave it, fine. I mean, you will lose out the marks. So do not be lazy. Work hard for studying all these chapters. You have the time in your hand now. Okay. So I think superstars, we have already done a lecture on current electricity in the 0 to Hero series. Some of you are saying B and C. Okay. Now let's do this. I'll tell you, because it is clearly mentioned, it is isothermal process. It is isothermal process. That means temperature is constant. Now if temperature is constant, what can you do? If temperature is constant, it is nothing but pressure into volume is constant. Now, if this is correct, then here is what I'm going to do. Okay, pressure into volume is constant. I can also say that the number of moles is constant. It's an isothermal process, so temperature is constant, pressure into volume is constant, even the number of moles are constant. So number of moles are also constant. That's something which I can say. So initial moles, N initial will be N final. The initial moles will be pressure into volume by N is PV by RT, R into T, plus the number of moles over there, 10P into volume by R into T. Finally, the pressure will be same everywhere. Let's say it is P1. What will be the total volume? Think about it. This is 5V, that is V. Total volume, what will it be? 6V, right? So it will be 6 times of V divided by RT. Why T? Because it is isothermal process. Clearly, RT goes. V goes. And from this will be 5P plus 10P. That's going to be 15P is equal to 6P1. Therefore, P1 will be, you can cut 3 from both sides. So it will be 5P by 2. So that's the final pressure. Yes, but that's not what has been asked. The question is, what is the volume of the gases? Okay, now if you take the left chamber, the chamber on the left side, because we know it's an isothermal process, I can say pressure into volume is constant. Now what is the initial pressure? It is P. What is the initial volume? That's 5V is equal to, what's the final pressure? Is this one, because this is the final pressure of the entire gas. So it will be P1 into the final volume, let's say V1. Okay, so now just substitute it. So it will be P into 5V. P1 is nothing but 5P by 2 into V1. So P will get cancelled, 5 will get cancelled. So V1 will be equal to 2V. So this is the volume on the left side. So how much will be the volume on the right side? If this is 2V, how much will be this? Because the total volume always has to be 6V. Keep this in mind. The total volume always has to be 6V. So it should be 4V, guys. And hence 2V and 4V, which is option A. 2V and 4V. A lot of you said C. That is wrong. It's A. Yes, Aman. Yes, Vishruta. Yes. Very few people got it. It's option A, guys. Got fooled. Yeah. Look at that, guys. Look at the look at your answers. Today a lot of questions. You guys are giving wrong answers. So that means clearly you need to work even harder. So learn from these questions. See what mistakes you have done. Yes. See what mistakes you have done. Okay, great. So let's get going. Don't worry, guys. Don't worry even if you got the wrong answers. If you understood with the explanation, if you understood the concept, that's a big deal. I mean, think about if you had not attended my class today, how many mistakes you would have made in the actual exam. At least you will not make those mistakes, right? That's something you should feel happy about. So come on, let's go into the next set of questions. But before that, let's talk about the theory for Carnot engine. Now, remember one very simple thing about engines and refrigerator. What is the job of an engine? It always takes energy from the hot side and puts it on the cold side. It takes energy. This is absorbs. Okay, it absorbs energy and it does some work and some of it will get released. Some of it will get released. So that's why the amount it absorbs will be used to do work and some of it will always get released. So this is a standard equation which you can use. This is the standard equation. This block diagram is very important. Very, very important. Okay. And the efficiency of an engine is how much work it does. That's what is there in the numerator. How much work it does upon how much it absorbs. If it absorbs a lot of energy, it's not efficient. If it absorbs very little energy and does a lot of work, then it's a very efficient engine. So that's why heat supplied to it, and heat supplied to it is nothing but Q1. Okay, this is what it is. Now, the efficiency of a Carnot engine is given by, you don't have to remember this formula, just remember this. 1 minus 1 temperature upon another temperature. Cold upon hot. That's all. So, this will be always the smaller one. This will be always the lower one. This will be always the higher one. Because obviously you have to get a number which is positive. So, when you subtract something from 1, that fraction should be less than 1, right? Else the answer will be negative. So, always lower by higher. That's how you can keep this in mind. Now, just keep one more thing in mind. For refrigerator, the block diagram is exactly opposite. It's exactly opposite, the arrow marks wise. This is your hot surrounding. This is your hot surrounding. Okay, this is your hot surrounding. This is your cold fridge, inside of a fridge. Okay, what it does, it takes away heat from the cold side and puts it into the hot surrounding. So this is the heat which is absorbed. Look at the arrow mark. This is the heat which is released, and this is the work which is done externally. That's the only change in the block diagram. This is the only change in the block diagram. Good morning, Frederick. Okay. Now, the thing is, remember, when you take heat from cold to hot, you need to do work because it is an unnatural process. Usually, the heat will always go from hot to cold like in an engine, and when the heat flows from hot to cold, some amount of work can be extracted out of it. But if you want to go the other way, if you want to send the heat from the cold side to the hot side, it is an unnatural thing. It's not what it wants to do. So that's why you need to do work to send the heat from the cold, which is inside the fridge, to the surroundings, which is hot. So that's why this block diagram is exactly reverse. And in the fridge case, there is something called as coefficient of performance. It's not efficiency, it's called coefficient of performance. What does the performance depend on? It depends on how much heat you could extract out of the fridge. If you can suck away lot of heat from the fridge, it's a better performer. And it is even better performer if you have to do very little work. So work is there below. Very little work you have to do. So hardly any work to suck away a lot of energy. So that is a very good performing fridge. That's how it is. Yep. I hope this is clear. Yep. So Vishruta saying, even I have spent 1 month on ray optics, even though I'm feeling what to do. So Vishruta and others, those of you who are facing problems in ray optics or anything, please let me know on my Instagram handle. Just ping me over there, or probably leave a comment after the video ends. I'll reply what you can do. Let's not break the flow of today's class, but don't worry, I will help you out. What should be the lecture series that you should watch, which books you should solve, which questions you should solve, I'll help you out with that. Okay, so just ping me on my Instagram handle. Let's see whether you can solve this question. Okay, yes, exactly, Aman. Just like you pay the bill for the refrigerator because you're doing work. I mean, electricity has to do some work to suck away the energy from the cold side and throw it to the hot side. Correct? Okay. Okay. Come on, guys. Think carefully. Oh, very good, Ankit. Glad your fuel got refilled. Okay. Come on. Think about this question. Okay. Come on. Figure it out. What do you think is the law which is followed when a system, there is a heat rejected and some of it is converted, some of the heat is converted into work? Which law is followed? Come on, think about it. Okay, come on, figure it out. Third, first, second, zero. Okay, guys, the answer is very simple. It is second. Thank you, Suyog. It is second law. Zeroth law is all about thermal equilibrium. This is thermal equilibrium law. If A is in equilibrium with B, B is in equilibrium with C, then A is also in equilibrium with C. That's zeroth law. First law is Q is equal to delta U plus W. Third law, nah. Second law is all about entropy and all that. It's all about work, how much work can be extracted out of a process where heat is flowing from hot body to the cold body. So it's exactly about this. This is all about Carnot cycle and heat which is extracted, work which is extracted from heat transfer from hot to cold body. So it says that there is a limit till which you can do work when heat flows from hot to cold. All the heat which flows cannot be converted into work. That's what second law is all about. So in case you forgot that, I'm just reminding you. Whenever heat flows from hot to cold body, complete heat cannot be converted into work. Only a part of it can be converted. Okay, so that's what it is. Let's see whether you can do this question. There is an engine, ideal engine, which has some efficiency eta. If you increase the hot temperature by 100 and even the cold temperature by 100, then the new efficiency will be more than the previous, less than the previous, or equal to the previous, or it depends on certain things. So Badri Narayan, don't prepare for VIT EEE is my best tip I can give for VIT EEE exams, because this exam is one of the easiest exam if you are preparing for mains. Please guys, do not prepare for VIT EEE. You are not meant to do that. You are supposed to prepare for JEE Mains. Understand that. When you prepare for JEE Mains, in the end, when the exam is going to approach, before that, just solve few papers of VIT EEE. That's it, because that exam is simpler than JEE Mains, number one. The number of questions are more. So if your memory is good, if you can recollect the formulas and you can calculate very quickly, you can crack that exam very easily. Remember that. Okay. Okay, come on guys. So Vikash, if you still have doubts, please ping me bacha on my Instagram handle or leave a comment after the video. I'll definitely help you out. Some of you are saying equal, some of you are saying C option. Okay, let's have a look. Let's have a look. Efficiency is 1 minus T cold by T hot. Okay, T cold by T hot. Now, example, I increase the numerator by 100. I increase the denominator also by 100. Let's see what happens to this ratio. First of all, tell me one thing. If I have a ratio x by y, and if I have x plus 100 divided by y plus 100, what symbol should I put? More than, less than, equal to? What do you think I should put? Take an example, right? Take an example and think about it. Rajaraman, are more 10 minutes? Yes, more 10 minutes or 15 minutes. We have 2 more questions or 1 more question. Yep. Okay, so what symbol do I put, guys? This is the catch. If you know maths properly, you can solve this question. If x by y is a ratio, x plus 100 by 100, y plus 100, what do you think should be the symbol out here? Take some example, you will probably get it. So guys, 5 by, I don't know, maybe 9, and you can take some example, 5 plus 1 divided by 9 plus 1. Okay, 5 plus 1 is nothing but 6, 9 plus 1 is nothing but 10. So which one is more, 5 by 9 or 6 by 10? Come on, is it more or less? Or cycle go, obviously it's not equal. It's obviously not equal. Come on, think about it. Which number is more or less? 10 5s are 50, 9 6s are, come on guys, you should be able to do this. 54, come on, one is 50, one is 54. So obviously it is like this, it's like this. Can you see that? Yes, I hope you know this. Come on, 10 5s are 50, 50 will come here, 9 into 6, 54, 54 is more than 50, right? Obviously, so it's not equal, it is this symbol, understand? So if you increase the numerator and denominator by the same amount, the ratio does not remain equal. Please get that in your head, okay? Please understand that, okay? Please understand this. Now, I hope you understood. The moment I increase numerator as well as denominator, the numerator as well as denominator by 100, what happened to this ratio? What happened to this ratio? This ratio has increased or decreased? Come on guys, answer in the chat box. Yeah, this ratio has basically increased. If this ratio has increased, when you are subtracting that ratio, you are subtracting a bigger number. Think about it, 1 minus that ratio. So if this number increases, if you subtract a bigger number, this eta, what will happen to this eta? It will decrease. Yes. So hence the answer is less than. The answer is less than. I hope this is clear. Everybody understanding this, why the answer has decreased? Because this ratio has increased. So understand that, this has, yep, correcto. So that's how it is. Okay, let's get going to the next question coming up on your screen. Come on, let's see how many of you can solve this. Let's see guys, come on, all my warriors, solve this question. The temperature inside and outside a refrigerator are so and so. For every joule of work done, how much heat will be delivered to the surroundings? Come on. Let's have a look. Okay, the temperature inside and outside of a fridge are this and this. What is the heat which is delivered to the surroundings approximately? Okay, come on warriors, let's do this. So first of all, what you need to do is, oops, where is that? Okay, first of all, what you need to do is draw the block diagram. This is, let's say, the hotter one, which is 303 Kelvin. Okay, this is the hotter one, 303 Kelvin, and this is the colder one, which is 273 Kelvin. And then you are doing some work which is 1 joule of work. You are taking out some energy, let's say it is Q1, and you are giving it to the hotter surroundings, let's say it is Q2. That's what is given. This is the block diagram. That is the first thing you should draw. This is the first thing you should draw. Okay, now the thing is guys, remember, this is hot temperature, this is cold temperature. In fact, 303 divided by cold temperature 273 is directly proportional to the heats as well. hot temperature by cold temperature is directly proportional to the hot side heat divided by the cold side heat which is absorbed. So it is actually Q2 by Q1, exactly equal to this. Remember that. Exactly equal to this. So basically what you can do now, use dividendo. Use dividendo. 303 minus 273 divided by 273 is equal to Q2 minus Q1 divided by Q1. Yes. Now what is Q2 minus Q1? Q2 minus Q1. Think about it. Guys, Q2 is equal to Q1 plus 1 joule. So Q2 minus Q1 is nothing but 1. Q2 minus Q1 is 1. So this is Q1 and this is nothing but 30 divided by 273. So therefore Q1 is 273 divided by 30. Yes, that's what Q1 is. So finally I will get Q2. Q2 is 273 by 30 plus 1, which is nothing but 300 yes, which is nothing but 303 divided by 30, which is approximately 10 joules. So this is basically the heat which is delivered. The heat which is delivered is Q2 and that's approximately 10 joules. Yep, I hope this is clear. Everybody understood this? Yes, this is 10 joules. That's the answer, guys. Beautiful. Excelente. Yep, that's the answer. Okay, now remember the crash course is starting, in fact it has started on 17th of May, that's yesterday. So if you want the replays of the yesterday session, you can still get it and you can start attending the classes live from today itself. Entire 11th and 12th standard syllabus with problem solving, with notes, the PDFs, everything, assignments will be provided to you and you're going to get the best teachers who are having an experience and history of producing results even this year and the last year. You will get unlimited doubt solving inside and even outside the class, the one like I just showed you. You'll also get test series, 20 test series with discussions out there. Okay, all of this you're going to get in the crash course at a very good price of just 6,000 rupees when you use the discount coupon SHCC. But if you want to avail a better offer, what you can do is, when you go to our description box out here, let me just pause this, and when you click on the JEE crash course, first of all you get an option to choose which date you want to start it. So let's say you choose 17th May, you can boost your rank, you get all the details like boosting your rank, and you will get strategy sessions plus 20 test series. And when you say buy now, okay, there is an option for EMI and you can even pay 2,000 rupees in installments. So you don't have to shell out 6,000 rupees also, you can even shell out 2,000 rupees, that's even less, and it can be easy on your finances as well. So all the instant doubt solving, support, the interactive classes and the test series is a part of the crash course. Go ahead, join it so that you can boost your score. Okay, that's it from my side, guys. Thank you very much. Yes, have a nice day ahead. Okay, take care. Bye bye. Ankit, don't worry, I'm not going anywhere. I'll be coming back again. Yes, very soon. Have a great time ahead. See you. This was Shreyas here.